Okay, we are live. Good morning. Uh-oh. I hear my kids crying already. All right, it is Wednesday morning, May 6th, 2020. Oh boy, yeah, that's definitely a crying kid. All right, hold on. I'm teaching right now. Sammy, come here, baby. Sammy. Sammy. Uh-oh. Okay. We'll see how that works itself out. This is a great teaching environment, right? Okay, let's actually get started. Well, there they are. Okay, they're getting it fixed. Okay, so welcome to the last stream of the year. If you haven't heard, this week is the last week of instruction. So after today, after this lesson, you have this one assignment to do, and then you are done. We don't have a final exam. So I'll go over a couple of the logistical things, how to actually close out the class, that kind of thing. And yeah, after the lesson, there's not really a reason to stream anymore. I'll be answering questions. I will be more than happy to hop on and just answer some questions if there are a lot of the same question from people. I mean, I'm still going to be available every morning pretty much until May 20th. But yeah, we don't have any lectures and dual credit's completely done. So yeah, I'm pretty much just here to answer questions at that point. So pre-cal, what all do you have left to do? So we've got polar graphs, which we're going to learn today. So we just learned what a polar coordinate was last week. We're going to put it into action. We're going to learn some graphs. I'm going to teach you. And honestly, the nice thing about this is there's a little bit of work to do concerning some of the numbers that you have to find, but 80% of this is on your calculator. So that's going to be pretty nice. And let's talk about what all you have to get done. So you've got polar graphs. So as far as this 6 weeks is concerned, you've got, I'm pretty sure we started with sum and difference. I forget which one was the very beginning one, but you've got 5 or 6 homeworks that you need to get done. And then you only have one test, right? So you're going to be assigned 2 things today. I haven't put this up yet, but your exam number 2 for this 6 weeks is to fill out my course feedback form, which I have not finished yet. You can see I'm working on it right now. But I'm going to post a link to that as your exam too. And whenever I see that you have turned it in, then yeah, you will get a test grade, which will be 100 because there's no grading this. I'm not going to go, oh, I didn't like what you wrote, I'm going to take points off. I'm not doing that. So, yeah, it's kind of bittersweet. Yeah, we're gonna be done with the class. One of the reasons we're doing that is because AP tests start next week, and you're gonna need all your brain power for that. And dual credit's done this week, and no one's giving a final, so there's not much left to do. Hopefully, I feel like what we've done this year, even with the remote online schooling, what we've done this year will prepare you for calculus next year. Even if that wasn't your goal, that was my goal. So you should feel pretty secure going into that class next year after we cover this section. And yeah, I'm always going to be available for questions even after you are done with me. So I still get emails from students I graduated asking for help in college. So I'm around. You might even have me for a Lee College class next year. Okay, let's see. I guess we should start this lecture now. Let me get out my handy little stylus here. For like a $3 little stylus, this has been working very, very well. It's been good. Okay, so what is a polar graph? What are characteristics of it? How do we use our calculator to get the answers, which is what most of you are asking. And I will show you all of that today. All right, so there are a couple of things that you're going to be asked. First of all, you have to graph it, which is going to be the big thing. So you're going to be provided a blank graph on every problem. You always are going to be r equals something in terms of theta. The theta, of course, is an angle, and just like before, with regular, it's going to be in degrees. With pre-AP, it's going to be in radians. There are 4 distinct shapes of polar graphs. Now, the nice thing about it is they all either use sine or cosine. So you're not going to have to worry about tangent or any of your cosecant, secant, cotangent ones for the rest of the year. And then you've got to figure out where your zeros are, where your r is equal to 0, and where your maxima are. So that's going to be the furthest out that your graph ever gets from the origin. And remember, when we say r, we mean the distance from the origin, and that was polar coordinates last time. You're going to be using your trig chart to find these values, so I'll show you how to do that with some of these examples. Okay. Let's just get to work. First things first, how do you draw a circle? So a circle is either going to be of the form r equals a cosine theta or r equals a sine theta. And of course, a is just going to be a number that gets filled in the problem. So you see the example down here, we have 4 sine theta. Now, I gave you a little, I mean, a lot of professors / teachers will ask you or expect you to do this without a calculator's aid. Those of you that take AP Calculus next year, juniors that are in pre-AP right now, if you ever get asked this, it's going to be on the non-calculator portion of the test. So you're going to want to know what all the properties are. You know, it's just a characterization, memorizing thing. So r equals 4 sine theta is just a circle that goes out to 4 on our little radial dial out here. And then sine theta, you notice on my little tooltip up here, it says it's on the y-axis. So if you go to the y-axis, it's going to be centered there. Now I'm going to show you how to use your calculator to get this answer. And this is going to be what you do, like I said, 80% of the time. Okay, before you start, a couple of things you need to note to change. Under mode, here, let me actually use my mouse cursor. So hit mode. And then right here, radian degree actually doesn't matter, but the one below it, by default function is highlighted. You want to head over to POL or polar, and you want to highlight that. So step 1, highlight polar. And then let me fix this to zoom standard first. So most of you are going to be in a standard zooming window. So whenever I type in 4 sine theta, like that. Hopefully you saw the little mouse cursor. It's supposed to be a circle, but notice how that looks really oval shaped. And it's on the y-axis, like I said it was going to be. So hit zoom, and you see option 5 says zoom square. That squares out the x or the x and y axis, so it actually looks proportional. And notice how 4 is not actually the radius of the circle. 4 is actually the diameter of the circle. It goes out 4 from the origin. So from 0, 0, goes out to 4. And don't worry too much about the exact, shape of the, obviously my circle looks terrible. As long as it pretty much looks similar to what the answer is supposed to be. And you'll see when you hit the assignment on Google Classroom, when you head down to the answer key. And we haven't gotten over that shape yet, but if we do a circle, let's see. There we go. So it does not have to look perfect. Okay, now let's talk about the minimums and the maxima, the minima and maxima, I guess. So as you go, remember polar coordinates, you start at 0 degrees and you spin around to 360. When is r equal to 0? Well, the whole r is going to be equal to 0 when the whole expression is equal to 0. So because sine, it's a sine function, anytime sine theta is equal to 0, the whole thing becomes 0 because 4 times 0 is still going to be 0, right? So you have to head to your trig chart, which you have a link to already. I may just re-paste it or re-copy it onto that other post just to make it easier for y'all. My goodness, I post way too much stuff. Where's that trig equations post that we did? There we go. So you head over to your trig chart, and this is going to be really useful for you. Where is sine equal to 0? And then the problem will say like 0 to 180 degrees or 0 to 360 degrees. So sine is going to be 0 at 0 degrees and at 180 degrees. So those are going to be where your minima lie. So r equals 0 at theta equals 0 degrees and 180 degrees. And if you're pre-AP, of course, this is going to be in radians, so 0 or pi. And then where's your max? Well, the maximum it ever extends from the origin is 4. So r equals 4 at theta equals, and then you head over to your trig chart and you want to find where sine is equal to 1. Because remember, on the unit circle, the radius is 1. So 1 would be the largest that the sine function ever gets. And here it's going to be 90 degrees. And that's the whole problem. For a circle. I mean, we're going to have other stuff. All right. Okay. I don't see any questions in chat yet. Okie doke. Hi, Sergiu. How's it going? All right. Okay, we're good on questions. Let's move right along. The next type of polar graph is called a limmason, or a cardioid is the, I guess, other technical name for it. Sorry, just got an email. Okay, so a limmason. So what does a limmason look like? Again, they're all going to be some form or sine or cosine. And then the way they're going to look, and for all of these, whenever it's asking you for the name of the graph, whatever, here, hold on. When it's asking you for the name of the graph, so let me pull up a limmason. You're going to see weird names like looped limmason and dimpled limmason. What are the other possible ones? Yes, the dimpled limmason right there. And then just a traditional limmason right there. There are technical differences between all three, but all you have to pay attention to is on the problem, do you have a number plus or minus some other sine or cosine, maybe with a number on it. Okay. The ratio of this number to this number determines whether you have a dimpled limmason or a looped limmason or just a limmason. There are technically 3 different types of this graph. I do not care if you do that in this whole problem. Just say limmason. Okay. Again, if you have a cosine, it's going to be based on the x-axis. If you have a sine, it's going to be based on the y-axis. You should be beginning this problem by typing it into the calculator. We'll figure out all the maxes and mins and stuff later. So r equals 3 minus 3 cosine theta. All right. So let's type it in. Oops. 3 minus 3 cosine theta. Hit our little graph. And you can zoom in if you want here, if you need a little more detail. So notice how right there, right on the origin, it's not a circle. It starts on the origin, dimples out a little bit, comes around in a circle, and then dimples back into the origin. So this is technically the shape of your cardioid. If you make it a sine graph, it kind of looks like a heart. That's why it's called cardioid. So let's zoom back to our normal square. Oh, whoops. Let's zoom out. Okay, so how far does it extend out? Well, it extends out to the left by 6. So you can count the little hash marks. The other reason why is, you know, cosine ranges anywhere from 1 to -1. So anytime cosine becomes -1, you've got 3 minus -3. So you'd have, sorry, 3 minus -3, which would be 6. And that doesn't happen until you're facing 180 degrees. There we go. So that's why you're going out by 6 over to the left. So again, graph does not have to be perfect, but it does touch the origin. The 6 circles right here. Then you've got some dimple. There we go. So it looks something like that. And as far as that graph looks anywhere close to that, then you'll be good. Now remember, cosine, sine or cosine can range anywhere from 1 to -1. So what are my minima? Where r could be 0 or r could be 6. When is my r equal to 0? Well, the whole equation would be equal to 0 if you ended up with 3 minus 3. Right? So I need cosine to equal 1, which doesn't happen until theta is 0 degrees. And then it would hit 1 again at 360 degrees, but this isn't going to go out that far. You just pay attention to the range of your graph. See, well, some of them do say 360, but it doesn't actually include the 360. So just saying 0 would be fine here. Technically, cosine would equal 1 at 360 degrees again, but it's not going to be included in the problem. All right, where would r equal to 6? I would need it to say 3 minus -3, so I need cosine to be -1, and that happens at 180 degrees. And again, you're just using your trig chart to figure these out. Just a cool thing to note, I guess, because I like this stuff. If you make this number proportionately bigger, so 5 is bigger than 3, notice how there's a little dimple, but it doesn't touch the origin, so that's called a dimpled limaçon. And if you make the number here bigger, then you have a little loop inside of your limaçon, so that's called a looped limaçon. So technically those are different shapes. We're not going to worry about it too much in pre-cal. Even in calculus, I mean, it gets covered at the end of the year. It gets asked on the AP test sometimes. I think you'll be okay if you don't know the specific differences between all of them. Okay, next graph. Rows. So there's a little bit of stuff to see here. You don't have a plus or minus here. You just have a number, but now notice how you have a number next or multiplied to theta. So you've either got a cosine n theta or a sine n theta. Cosine or sine just determines where your first petal is, whether it's centered on the x-axis or centered in quadrant, or I forget what would be quadrant 1. Okay, so if n is odd, a rose has n petals. So if you have 5 or something there, you have that many petals. If you have an even number there, it has twice that many petals. So I'll show you that in a second, because we have an odd number in this example problem. So 4 cosine 3 theta. So your first petal is going to be centered on the x-axis. It goes out to 4. And we should have 3 petals on our rose. So let's take a look at our calculator and see what it looks like. So you've got 4 cosine 3 theta. If we take a look at this graph, we've got a rose. Okay. So there's your rose. So it starts right here. And then it does this here. If we want to follow this shape, it does this weird thing where technically comes out like this. Oh wait, I didn't go out to 4. Whoops, let me redo that. Okay, so I need to go out to 4 here. I need to go out to 4. And then here, I guess let's do the numbers first to make it look as exact as possible. Your minimum radius is going to be 0. Your maximum radius is going to be 4. But notice how you have 3 theta here. So when is cosine equal to 0? Let's actually flip back over to the trig chart. When is cosine equal to 0? Well, it's equal to 0 at 90 degrees and at 270 degrees. So I'm going to write it off to the side here. So cosine theta equals 0 at 90 and 270. And then technically that's periodic, right? So you could add 360 to both of those and you could figure out other zeros in the problem. So we're going to do that. So add 360 here, you get 450. Add 360 here, you get, let's see, 630. Now, we're going to do the same thing for where is cosine equal to 1. Cosine is equal to 1 at 0 degrees and at 360 degrees, so at the very beginning and end. Oh, this is going to be behind my overlay, but sorry, y'all. So cosine theta equals 1 at 0 degrees, 360 degrees, and of course 720 degrees, 1080 degrees. So those are all the places where cosine hits the maximum. And then where is cosine equal to -1? Actually, you know what? Let me rearrange it. Because we don't care if it hits plus or -4, right? Because a -4 would still have a radius of 4. It would just go in the opposite direction. So we'll just write a little plus minus. We'll just condense everything into one list. So 0 degrees, 180 degrees, 360 degrees, 540 degrees, 720 degrees. I think that's far enough. I think that's far enough. 900. Oh no, 900 gets covered. Okay. Okay, so when is the r equal to 0? That's anytime cosine's equal to 0. So this problem has a 3 theta here. So in order to solve for theta, I've got to take all of these numbers and divide by 3. In order to solve for theta, if I'm doing that trig equation thing from 2 lectures ago, and I'm trying to figure out where theta is equal to 0. Okay? So theta, when is the thing equal to 0? When do I hit the origin? Anytime I'm at 30 degrees or 90 degrees. And then you're going to have to pay attention to what range of numbers they want in the problem, because you could technically keep going forever and ever to infinity. But 150 degrees. I'm assuming that's probably all they want in this problem. They probably only go to 180. And then r equals, and then I think they do like a little absolute value thing here in your answer key. Let's let me make sure I do what the answer key says so no one gets confused. Yeah, so they do an absolute value thing. Or they put it on the r here. We'll make it look just like them. Okay, so absolute value of r could be 4. And then I'm just going to take all those numbers up here and divide them by 3. So that's still going to, 0 divided by 3 is still 0. So I'm still going to hit my maximum at 0, which explains why my first petal starts right there at 0 degrees. But now you've got 60 degrees. You've got, let's see, 120 degrees. That's probably all they want. I don't know. Well, I guess we'll do 180 just to be safe. All right, so that explains why the graph looks the way it does at the places that it does. So the petal on the top, on the bottom left, is a negative radius at 60 degrees, and then the petal that's over here at 120 degrees is the positive r at 120. So let's head back to our graph. So negative 60 is going to be right here at 240. So we'll do our petal right here. And then we want a petal at 120 with a radius of 4 as well. So that's the logic behind where the 3 petals come from. If you pay attention to the order that it actually traces it here, let me clear it out. And then if you just pay attention to the actual, calculator drawing the line for you, it gives you a hint to, the order that you should draw it, if you want to make it really nice. See? It followed that exact same order we did. Okay, other things to note with the rows is if you mess with the numbers here, I'll just play around with it. Let's change it to an even number. Yeah. You actually end up with 8 petals, which is kind of cool. And again, that's all just based on the trig chart dividing everything by 4 and the fact that you have way more numbers to deal with. Messing with this number just changes how big the petals are, changes your radius, just makes it wider, see? So you can go crazy and make it like 12 or something. There you go. Fun graphs. Yeah, don't get too crazy. You'll start crashing your calculator, but... Oh no, where's my theta? I'm just goofing off here. Whoa, 20 petals. Okay, all right, I've made my point. Okay, final shape should be a lemniscate, I think. Yeah. So a lemniscate, it's very obvious whenever you see it because it's an r squared. It's the only one with an r squared. The number inside of theta is always going to be 2. And you might think, oh, that looks just like a rose. It has, you know, it should have 4 petals. It actually doesn't because r is squared and you have an a squared there. So in this problem, since a squared, my example problem has 25, the max radius of my problem is actually going to be 5 because technically if I were doing the math, I would be square rooting both sides here to solve for r. This is tricky. Let's see. The hardest part about this problem is that this one you don't really want your calculator, and in fact you kind of can't, because if you just try to do, because you can't type in r squared, it has to be r. So if you just try to type in like square root of 5 sine 2 theta or something like that, you're only going to see half of the graph because you know you can't do a plus minus or anything. It's not a function anymore. Oh, I guess on sine ones you do. Oh, because, oh, that makes sense because the negative is just going to be, oh, I guess this does work. Let me make sure the cosine one works. Yeah, okay, never mind. I lied. It works. You can type it in your calculator. You just have to square root both sides. Oh, this 5 should be on the outside. Whoops. I'm making this way too small. Yeah, because it's supposed to be out to 5. Zoom out. There we go. Okay, so, hey, might as well just do this. Right, I forgot if I changed it. No, I changed it to a cosine. Huh, I've always been taught that you can't type lemniscates in the calculator. The reason why you really shouldn't is because technically, because it's an r squared, you shouldn't. You're missing the plus minus whenever you square root both sides. It just traces itself again, so technically it goes over itself twice. But hey, the calculator shows you the answer, so who cares? So we go out to a radius of 5, and it's going to be centered on the y-axis. Or sorry, centered in quadrant 1 and quadrant 3. Where's 5? There? If it were a cosine one, you would just go straight on the x-axis at 0 and 180. You could technically do all the math you did with the rows to figure out where the thetas are, but even though we're square rooting, sine of 2 theta is going to hit its maximum at 90 degrees and wait, hold on, 90 degrees and then 450 degrees. One at 90 and 450, and that's just off your trig chart. Because it's a 2 theta, you divide both those in half. So r is either going to be 0 or r is going to be 5 at theta equals 45 and 225. And all lemniscates are going to be centered at 45 degrees because that little number next to theta is always going to be 2. So r is going to be 0 when theta equals 0, and then sine is equal to 0 at 0, 180, 360. I guess we'll write it. 0 at 0, 180, 360, 540, I guess. I don't know. But you divide all of those by 2. So at 90, then I don't know how far they're going to ask you to go here. 180, 270. There it goes. So a lemniscate literally just looks like a 2-petaled rose. Which never happens in the rose equation, because if you try to make the little thing 2, it doubles to 4. If you try to make it 1, it stays 1. So the only way to get a 2-petaled rose is with a lemniscate. And yeah, like I said, most of this starts off with your calculator, and you just try to use your trig chart to come up with the logic for where the maxima occur. And that's your last lecture. Yeah, can't believe it, that's it. Alright, so I will post this annotated lecture up. I'll post a video. I will reattach the trig chart to this post to make it a little easier for you. And yeah, I guess that's pretty much it. Pre-cal, I'll be posting a course evaluation survey. That's going to be your test number 2. And yeah, just take the the due date's set to Tuesday, so we'll set the exam 2 to quote-unquote to Tuesday as well, so you can just be done with the class on Tuesday. And then from then on, it's just turn in late work if you have any late work. Dual credit. Oh, actually, all of you. Extra credit. I'll fill out all of your rubrics, and I'll try to hand them back to whoever turned in the presentation. But I can't actually put your grade in until quote-unquote finals week, whenever we actually put in our final grades that week of May 18th. So I'll just manually add it into your final averages after the stuff from this 6 weeks checks in. Okay. All right, that's a wrap. Thank you very much for tuning in. For those of you that watched the videos, that tuned in the morning, I really appreciate it. Thank you for waking up with me. And we got a couple of lurkers in the chat, but other than that, everyone else, thank you. I will see you later. Email me if you need anything from me, but that is the Twitch stream shutting down for spring. Bye.